Today, we're going to discuss differentiation formulas. So let's start with the properties. So number one, it is the derivative of the sum and difference of two functions. So can be written as the quantity of f of x plus or minus g of x then prime. So the prime there is the notation for taking the derivative, or we can solve that one as by taking the derivative of each term. So we can write now as f prime of x plus or minus g prime of x. Or the other notation for that is that saying that taking the derivative of, or shall we say, d over dx of the quantity of f of x plus or minus g of x is equal to the derivative of the function f with respect to x plus or minus the derivative of the function of g with respect to x. In other words, to differentiate a sum or difference, all we need to do is differentiate the individual terms and then put them back together with the appropriate sign. Note as well that this property is not limited to two functions. So we can use more than two, more than three, or many terms as we can, or many functions. And property number two, so we have the derivative of c times f of x is equal to c times the derivative of f, which have f prime of x. So c there is a constant. So to take the derivative of that, we will just multiply the constant multiplier and then take the derivative of the function of x. So we can write now c times f prime of x, which is the derivative of f of x. Or you can write in this form, d over dx of c times f of x is equal to c times the derivative of the function with respect to x, and c there is any number, or it is known as a constant. So formula number one, if f of x equals c, then f prime of x is equal to 0. In other words, so the derivative of a constant is equal to 0. And formula number two, if f of x equals x raised to n, then the derivative of f of x, which can be written as f prime of x, is equal to n times x to the power of n minus 1. It means to say the exponent will be multiplied to the coefficient. So that's why we have here n times x, and then the exponent will be subtracted by 1. So in this case, we assume that the coefficient of x is 1. That's why n times 1 equals n times x to the power of n minus 1. So we call this formula as the power rule. So let us try to apply the first two formulas that we encountered. So the given is f of x equals 15x raised to 100 minus 3x to the power of 12 plus 5x minus 46. So we are going to differentiate each of these using the formulas. Unlike on the last topic, we take the derivative by using the definition of the derivative, wherein it is quite long to show the solution for that. So for now, your life will become easier using the differentiation formulas. So to solve for this now, we are going to apply the power rule. At the same time, we apply the property number one, which is the sum or difference of two functions. So we can write now, we have f prime of x. So f prime of x is the symbol for, or notation for, the derivative of f of x. So using the formula of the power rule, we have 100 is the value of n times the coefficient. So we can write here 100 times 15 of x raised to 100 minus 1, because it is stated that the exponent will be subtracted by 1. Now on the second term, I have negative 3 times the exponent is 12, x to the power of 12 minus 1, plus, since the exponent of 5x is 1, so 1 times 5 is just equal to, I will write here 1 times 5 of x raised to So since the exponent of x is 1, so I will write first 1 and then subtract by 1 according to the formula of n minus 1 in the exponent. So therefore we have there 1 times 5 of x raised to 1 minus 1 minus, and applying the first formula, that it says that the derivative of a constant is equal to 0. That's why the derivative of 46 now is 0. Now simplifying this one, we have 100 times 15 is equal to 1,500 of x raised to 100 minus 1 is 99 minus 3 times 12 is 36 of x to the power of 11, because 12 minus 1 is 11, plus 1 times 5 is 5 of x raised to 0. So that the last term is 0, no need to write for 0. But this one is not yet the final answer, because from the knowledge of law of exponent, that any number raised to 0 is equal to 1. So therefore, the last term can be written as, so I'll copy first this one, 1,500 of x raised to 99 minus 36x raised to 11 plus uh, 5 times the meaning now of x raised to 0 is equal to 1, because any number raised to 0 is equal to 1. So therefore, the last term now will be multiplied by 5 times 1. So finally, our answer will be, we have now 1,500 x raised to 99 minus 36 x raised to 11 plus 5. So that is now our answer for number 1. Now for number 2, we have the function of g of t is equal to 2t raised to 6 plus 7t raised to negative 6. So applying the first two formulas or two properties, we have the addition of two function. At the same time, we're going to use the power rule. So we can write now g prime of t is equal to 2 times 6 of t raised to 6 minus 1 plus 7 times negative 6 of t raised to negative 6 minus 1. So simplifying this one, we have 2 times 6 is 12 of t to the power of 5. Positive 7 times negative 6 is negative 42 of t to the power of negative 7. If we want to avoid writing negative exponents, so we can simplify the second term. So we can write now as 12t raised to 5 minus 42 over t raised to 7. So this is now our answer for number 2. Now for number 3, we have y equals 8z cubed minus 1 over 3z raised to 5 plus z minus 23. So in our given, the second term is not yet in the proper form of writing the given. So what I'm trying to say is that we are going to write z raised to 5 in the numerator. So if we're going to do that, then we have to change the sign of the exponent if we're going to write in the numerator. So I can rewrite first the given as y is equal to 8z cubed minus 1 over 3 of z to the power of negative 5 plus z minus 23. Now, the given is ready for taking the derivative using the power rule as well. So therefore, we can write now, I can write the symbol of the derivative of y. You can write either y prime, or you can write also as dy over dz. So I write there over dz because the right hand side, the variable there is in terms of z. So as I've said a while ago, this can be also equal to y prime. So that's the other notation of taking the derivative. So in this case, we have now 8 times 3 is 24 of z to the power of 3 minus 1 equals 2. So therefore the exponent is 2 minus 1/3 times negative 5. It gives us the answer of 5 over 3 of z to the power of negative 5 minus 1 from the formula of the exponent. So therefore we have now negative 6 plus we have the exponent of z is 1. So I will show it here. We have 1. So since it's only 1, so 1 times 1, which the coefficient is 1. So 1 times 1 is 1. So therefore, it's just 1z. 1 times z is z, and then raised to the power of 0. Why it becomes root power of 0? Because the exponent is 1, then subtracted by 1. So 1 minus 1 is 0. Minus the derivative of 23, which is a constant according to the formula. It says that the derivative of a constant is 0. Now, simplifying this further, we can write now y prime is equal to 24z squared plus, so avoid writing negative exponents, so I can write z now in the denominator, but we are going to change the sign. So we have now 5 over 3z to the power of 6, and we know that z raised to 0 is equal to 1, because what I have said earlier on the first example, that any number raised to 0 is equal to 1. So therefore, I will write there 1. So this is now our final answer, which is the derivative of the given function is equal to 24z squared plus 5 over 3 of z raised to 6 plus 1. So in the next example, we have t of x equals the square root of 3 plus the cube root of x raised to 7 minus 2 over the fifth root of x squared. Well, I guess I need to change that one. Okay, I will just transfer this one to the other page. So we have x squared. So before we are going to take the derivative of that using the differentiation formulas, so we are going to convert the radical form into a fractional exponent. So for the first term, we can write now the square root of x can be written as x raised to 1 half plus 9 times, we have the cube root of x raised to 7 can be written as x raised to 7 over 3 minus, we have 2 over the fifth root of x squared can be written as 2 over x raised to 2 fifth, or this could be written now further as x raised to 1 half plus 9x raised to 7 over 3 minus 2x to the power of negative 2 over 5. So since we transfer the position of the denominator, so therefore we have to take the negative sign if we're going to write that one in the numerator. So we are going now to take the derivative after rewriting the given in terms of fractional exponent. So we have to write now t prime of x, which is the symbol for derivative, is equal to 1 half times the coefficient is 1. So therefore 1 half of x raised to 1 half minus 1. I will show it first. Then later on, I'm going to simplify. So plus 9 times 7 over 3 of x to the power of 7 over 3 minus 1 minus 2 times negative 2 fifth of x raised to negative 2 fifth minus 1. Now simplifying the exponent, which I have shown the by subtracting 1 to the exponent. So simplifying that one, we have 1 half of x raised to 1 half minus 1, that is equal to negative 1 half. So for you to easily subtract, you change 1 in terms of a fraction form. So since the denominator is 2, then you can replace now negative 1 by 2 over 2. So it becomes now a similar fraction. So 1 half minus 2 over 2, since the rules are in adding or subtracting similar fractions, we are just going to subtract the numerator and copy the denominator. So therefore, 1 half minus 2 over 2, or shall we say 1 half minus 1 is equal to negative 1 half. Plus, we have 9 times 7 over 3. So we can use cancellation with 9 and 3. So 9 divided by 3 is 3. So we can cancel this one, cancel 3, and this becomes now 3. So therefore, we have 3 times 7 is equal to 21 of x to the power of 7 over 3 minus 1 is equal to 4 over 3. Why it becomes 4 over 3? Because 7 over 3 minus 1. So the negative 1 there, I can change that one in terms of 3 over 3. So therefore, 7 minus 3 is 4. Copy the denominator of 3. That is why you have there 4 over 3. Now, on the last term, we have negative 2 times negative 2 fifths. So the product is positive 4 over 5 of x raised to, then negative 2 over 5 minus 1. So the difference now is equal to negative 7 over 5. Why it becomes negative 7 over 5? Because you can change easily negative 1 by negative 5 over 5 because negative 5 over 5 is equal to negative 1. So I just make the fraction in terms of a similar fraction. So therefore, negative 2 minus 5 is negative 7 over 5. Now, if I want to write the answer in terms of positive exponent, so therefore, we have t prime of x is equal to 1 over 2x raised to 1 half plus 21x raised to 4 over 3 plus 4 over 5 of x raised to 7 over 5. Okay, next example, we have y equals the cube root of x squared times 2x minus x squared. Now, if you are going to use only the first two formulas that I've shown earlier, that is in terms of the sum or difference of the derivative, as well as the derivative of a constant is equal to 0, then in that case, we need to use first our knowledge in algebra. So in other words, we need to use distributive property before we can take the derivative. But sooner or later, I'm going to introduce to you how to find the derivative of a product and a quotient. So for now, we're going to manipulate first the given before we are going to take the derivative. So in this case, I will rewrite first the cube root of x squared in terms of fractional exponent. So this can be written now as y is equal to x to the power of 2 thirds times 2x minus x squared. Using the distributive property, we have x to the power of 2 thirds times 2x. So we can write now 2x and then add the exponents of 2 thirds plus 1. So it gives us now the exponent of 5 over 3. So actually, we're only using the law of exponents when we multiply with the same base. So we added the exponents. So minus, we have x raised to 2 thirds times x squared. So we are going to add the exponents of 2 thirds plus 2. That will give you the answer of 8 over 3. So we have x to the power of 8 over 3. So from there, we can now take the derivative. So I can write as y prime, or if you like, you can write as well as dy over dx. So dx because the right side is in terms of x. So we can write now what is 2 times 5 over 3. So multiply the coefficient times the exponent. That's why 2 times 5 over 3. Or you can write 5 over 3 times 2, whichever you like to the then x the power of 5 over 3 minus 1 is equal to 2 thirds minus 8 over 3 times negative 1. So we can write now 8 over 3 of x to the power of 8 over 3 minus 1. It will give you the answer of 5 over 3. So simplifying further, so we can write now the answer of we have 2 times 5 over 3 is 10 over 3 of x to the power of 2 thirds minus 8 over 3 of x to the power of 5 over 3. So this is now the derivative of the given function. Now for the next number, we have in a ratio form or in a quotient form. So before we're going to use the the quotient rule in finding the derivatives. So let us manipulate first by dividing each term. So we can write now, we have f of x is equal to 2x raised to 5 plus x squared minus 5 all over x squared. So dividing each term now, 2x raised to 5 over x squared. So the quotient now is 2x raised to 3 plus x squared divided by x squared is equal to 1 minus 5 over x squared. So since the last term is not yet in the proper form, before we take the derivative, so I will write x squared to the numerator by changing the sign. So we can write now f of x is equal to 2x cubed plus 1 minus 5x to the power of negative 2. Now from there, we cannot take our derivative. So f prime of x is equal to 3 times 2 is equal to 6. X to the power of 3 minus 1 equals 2. So the exponent there is 2. And the derivative of 1, which is a constant, therefore the derivative of a constant is 0. So plus 0, but I will not write anymore, minus negative 5 times negative 2 is positive 10. So I write there positive instead of minus sign because of the negative 5 and the negative 2. So the product is positive 10 of x to the power of negative 2 minus 1 is negative 3. So changing the answer now in terms of positive exponent. So therefore, f prime of x is equal to 6x squared plus 10 over x cubed. So this is now our final answer. Now for the next number, we have f of x is equal to 10 times the fifth root of x cubed minus x raised to 7 minus the square root of x raised to 7 plus 6 times the cube root of x raised to 8 minus 3. So first thing, we are going to rewrite the given in terms of fractional exponent. So we can write now, we have f of x is equal to 10 x raised to 3 fifths minus x raised to 7 over 2 plus the next term we can write as 6x raised to 8 over 3 minus 3. So after writing the radical form into fractional exponent, that's the time we are going to take the derivative. So we can write now f prime of x as the notation of our derivative. So we can write now 10 times 3 fifths. We have 10 times 3 fifths. So the product is 6. So we can write here 6x to the power of 3 over 5 minus 1 because we need to subtract 1 to the exponent. So the answer is negative 2 2/5 minus the exponent will be multiplied to the coefficient which is invisible 1. So therefore we can write negative 7 over 2 of x raised to 7 over 2 minus 1. We have 5 over 2. And the next term we have 6 times 8 over 3. So the product now is equals 16 of x to the power of 8 over 3 minus 1. That will be equal to 5 over 3. And the derivative of 3, wherein 3 is a constant, therefore the derivative of 3 is 0, so no need to write 0. Since I can see that there is a negative exponent, so I will rewrite our answer now in terms of positive exponent. So therefore we have f prime of x is equal to 6 over x raised to 2 fifths minus 7 over 2 of x raised to 5 over 2 plus 16x to the power of 5 over 3. Now on the last example, we have r of z is equal to 6 over the square root of z cubed plus 1 over 8 z raised to 4 minus 1 over 3 z to the power of 10. So first thing, I will rewrite that one in terms of fractional exponent. At the same time, I'm going to write that one in the numerator. So I can write this one will be equal to, we have 6z to the power of negative 3 halves plus we have 1 over 8 of z to the power of negative 4 minus 1 over 3 of z to the power of negative 10. So on the first term, it is the square root of z cubed can be written as z to the power of 3 halves. So when I write that one in the numerator, that is why I write there the power of z now becomes negative 3 over 2. Okay, so after that, we have to take the derivative. So r prime of z is equal to multiply the exponent with the coefficient. So we have 6 times negative 3 over 2 is equal to negative 9. So I have negative 9z to the power of negative 5 over 2 because negative 3 halves minus 1. And on the second term, we have to multiply negative 4 times 1 over 8 equals negative 1 half. So I can write here negative 1 half of z to the power of negative 5 because negative 4 minus 1 equals negative 5. And on the last term, I have negative 10 times negative 1 third. So the product now will give us positive 10 over 3 of z to the power of negative 11. Now rewriting the answer in terms of positive exponents, so I can write now negative 9 over z to the power of 5 over 2 minus 1 over 2 of z to the power of 5 plus 10 over 3 z to the power of 11. So this is now our final answer. So next we're going to discuss about the product rule and the quotient rule. So it says that if the two functions f of x and g of x are differentiable, that is, the derivative exists, then the product is differentiable. And the notation is, so the quantity of fg of prime is equal to f prime of g plus fg prime. Or sometimes, if we are going to use another variable, for example, I will let x, if f of x now, I will let that one as u, and g of x is equal to v, then using the product rule, we can write now uv, the derivative of that, is equal to u times the derivative of v plus v, the second term, times the derivative of the first term. So this is another formula. Instead of writing the, the derivative of fg is equal to f prime of g plus fg prime. So I would like you to remember this formula instead of the first formula that I write. So if the two functions is in terms of u and v, then you to take the derivative of the product form, write first the first element, which is now u, then take the derivative of the second element, which is now the derivative of v is dv, plus you write first now the second element, which is v, then take the derivative of the first element. So I would like you to use this one because it would be easier to memorize the product rule. If the two functions now is u and v, therefore the derivative of uv is equal to u dv plus v du. Okay, so let us try to use that one later on. But before that, we have the rule of the quotient. So if the two functions of f of x and g of x are differentiable, that is, the derivative exists, then the quotient is differentiable. Now, we have the derivative of the quotient, the derivative of f over g is equal to f prime of g, means to say the derivative of the first term, the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator all over g squared. Or I can also use my other notation. If f of x is represented by u and g of x is represented by v, so I can write now as the derivative of u over v will be equal to, we have the denominator times the derivative of the numerator minus the numerator, which is our u, times the derivative of the denominator all over the square of the denominator. So it's very easy to memorize that one. So the derivative of u over v is equal to v du minus u dv all over the square of the denominator. So let us have now our example. Differentiate each of the following functions. So by this time, we are going to use the formula for the product rule. So first of all, I will change the given of the cube root of x squared into a fractional exponent. So I can write now as y is equal to x to the power of 2/3 times 2x minus x squared. So I will let this one now. This will be my u, and the other terms will be my v. So using the formula, so the derivative of u over v, so derivative of that, the derivative of u over v is equal to u times the derivative of the second term plus the second term, which is v, times the derivative of the first term. So applying that, so we can write now, so we can write now as we have y prime is equal to our u there is x raised to 2/3 times, I will show it first that the derivative of the second term we have d over dx of 2x minus x squared plus the second term, which is 2x minus x squared times the derivative of the first term, which is x raised to 2/3. So I'm only plotting the given using that formula. So if you encounter d over dx of something, it means to say you are going to take yet the derivative. So let's take the derivative now. So we can write now here as y prime is equal to x raised to the power of 2/3 times the derivative of 2x is 2 minus the derivative of x squared is negative 2x or 2x, then plus the second term we have 2x minus x squared times the derivative of x to the power of 2/3 can be written as 2/3 of x to the power of 2/3 minus 1 is negative 1/3. Then after that, so using distributive property, so we can write now x to the power of 2/3 times the quantity of 2 minus 2x. So we can write the product as 2x raised to 2/3 minus 2x times x to the power of 2/3 can be written as negative 2 of x to the power of, you add the exponents of x, we have 2/3 plus 1 is equal to 5 over 3. So we have negative 2x the power of 5 over 3 plus the second term now we have 2x minus x squared times 2/3 of x to the power of negative 1/3. So using distributive property, we have 2 times 2/3 is equal to 4 over 3, and add the exponents of x. We have x, we have the exponent here is 1, so 1 plus negative 3. So the product of x times x to the power of negative 1/3 will be x to the power of 2/3 minus the second term now, we have x squared times 2/3 of x to the power of negative 1/3. So since the coefficient here is 1, so negative 1 times 2/3 just equal to negative 2/3, and x to the power of, you add the exponents, we have 2 plus the negative 1/3, or simply subtract 2 minus 1/3. So the answer now is equal to 5 over 3. So since I have noticed that there is like terms, so the like terms here is in terms of x to the power of 5 over 3, as well as the uh, in terms of x to the power of 2/3, we also have here 2/3. So combining like terms, so we can write now as y prime is equal to, in terms of the power of 2/3, so we can write now the answer of 2x to the power of 2/3 plus 4 thirds of x to the power of 2 thirds. So it will give you the sum of 10 over 3 of x to the power of 2 thirds. And in terms of the exponents of 5 thirds, so we have negative 2 x to the power of 5 thirds and negative 2 thirds of x to the 5 over 3. So it will give us the sum of negative 8 over 3 of x to the power of 5 over 3. So what I did there is just adding the coefficients of 2 and 4 over 3. So 2 plus 4 over 3, it will give you the sum of 10 over 3. And negative 2 as the coefficient of x to the power of 5 thirds as well as negative 2 thirds. If you're going to add that one, it will give you now the answer of negative 8 over 3. So that is why our final answer now will be y prime is equal to 10 over 3 of x to the power of 2 thirds minus 8 over 3 of x to the power of 5 thirds. So for number 2, so f of x is equal to 6x cubed minus x times the quantity of 10 minus 20x. So using the product rule, so our formula is the derivative of, so we have the quantity of uv, the derivative of that is equal to u dv plus v du. So our first term is, this is our u and this one is our v. So we can now solve for that. So using u dv, we have now 6x cubed minus x times the derivative of v. We have, this is our v, so derivative of that. So derivative of 10 is 0 and derivative of negative 20x is negative 20 plus we have the second term, we have v, so we can write now v. We have 10 minus 20x times the derivative of the first term, which is the derivative of u. So derivative of 6x cubed is 18x squared and derivative of x is 1. So simplifying that one, we have 6x cubed minus x times negative 20. So using distributive property, so negative 20 times 6 is negative 120x cubed plus negative x times negative 20 is positive 20x. And then, so 10 times 18x squared using the FOIL method. So we have the first terms are 10 times 18x squared. So the product now will be 180x squared. Then outer terms, so we have 10 times negative 1 is positive 10. Then inner terms are this. So negative 20 times 18 is equal to negative 360 of x cubed. And the last terms, we have negative 20x times negative 1 is positive 20x. Now, after that, we are going to combine like terms. So we have, in terms of x cubed, we have negative 120x cubed and negative 360x cubed. So it gives us the sum of negative 480x cubed. Now, in terms of x squared, we have 180x squared. So that's the only one. So we just copy. We have plus 180x squared. Now, in terms of x, so we have 20x here and the other 20x. So therefore, the sum is 40x. And the remaining term, okay, this must be negative 10 because 10 times negative 1 is negative 10. So the last term now will have the negative 10. So therefore, the derivative of f of x is equal to f prime of x is equal to negative 400. So f prime of x now is equal to negative 480x cubed plus 180x squared plus 40x minus 10. Now I can also write the other solution for that using the long method. So I'll copy first the given using the long method. or I would say, or shall we say the long method. Okay, I'll write first the given x. So if this is now my u, and this is my v, so I will pick up all of those given. So using the formula now of uv, the derivative of that is equal to u dv plus v du. If I'm going to write first the given of u, which is now 6x cubed minus x, and we have v is equal to 10 minus 20x. Now after that, you take the derivative of u and the derivative of v. So we can write derivative of u is equal to 18x squared minus 1. Derivative of x is 1. And the derivative of v, you can write dv. So derivative of 10 is 0. And the derivative of negative 20x is equal to negative 20. Now, substituting this one to our given, so we have now f prime of x is equal to u dv plus v du. So after knowing the value of u, v, du, and dv, so by substitution to our formula, so we have u is 6x cubed minus x times dv is negative 20 plus v is 10 minus 20x times du is 18x squared minus 1. So by simplifying, 6x cubed times negative 20 is negative 120x cubed. Negative x times negative 20 is positive 20x plus, so binomial times binomial, so we'll try to use the FOIL method. So 10 times 18x squared. So the product is 180x squared. And then outer terms, so we have 10 times negative 1 is equal to negative 10. Then inner terms, we have negative 20 times 18. So the product is negative 360. So negative 360 of x cubed. And the last terms, which is the product of negative 120 times negative 1 is positive 20x. So positive 20x. Now after that, combining like terms, so negative 120x cubed and negative 360x cubed. So the sum of that is negative 480 of x cubed. Then in terms of x squared, so there's only one term in terms of x squared, so we just copy that one. So 180x squared. And we have, in terms of x, we have 20x, another 20x, so a sum of 40x. And the last term, which is now negative 10, so just copy negative 10. So therefore, the derivative now of the given function is equal to negative 480x cubed plus 180x squared plus 40x minus 10, which is just the same on my solution number 1. Now, next we have here, the last two examples here is in terms of a quotient. So therefore, we're going to use the quotient formula. If this is equal to u over v, so the derivative of the quotient will be equal to v du minus u dv all over the square of the denominator, which is v. Now, using that formula, so I can write now here as w prime of z is equal to the denominator, which is now 2 minus z times the derivative of the numerator, which is 2z plus 9. So I'm just showing it yet that we're going to take the derivative of the numerator minus the numerator, which is now 3z. This must be 3z, not 2z. We have 3z plus 9. So minus the numerator, which is now 3z plus 9 times the derivative of the denominator, d over dz of the denominator is 2 minus z all over the square of the denominator, which is now v squared. So we have 2 minus z squared. Now, let's take the derivative of this one. We're going to take the derivative of that as well as this one. And then after that, we simplify. So writing first the other factors, we have 2 minus z times the derivative of 3z plus 9 is just equal to 3 minus the numerator, we have 3z plus 9 times the derivative of the denominator, of which is 2 minus z. The derivative of 2 is 0. The derivative of negative z is negative 1 all over the square of 2 minus z. So simplifying the numerator, we have 2 minus z times 3, so gives us the product of 6 minus 3z minus we have, or we can write now, since it's only monomial, I can multiply now. Negative 1 times negative sign is positive, and then 1 times 3z plus 9 is just the same as 3z plus 9. Or, if you like, you can just use distributive property yet, but you have to write negative, then after negative sign will be the open parenthesis, so that you will not forget to multiply the negative 1 outside. So this will be all over the square of the denominator, which is now the square of 2 minus z. By simplifying, so since we have negative 3z and positive 3z are additive inverse, so we can cancel that one. It gives us 0. And 6 plus 9 equals 15. So we can write 15 over 2 minus z, the square of that. Or we could say 15 over the square of 2 minus z. So this is now the derivative of the given function. Now for number 2, I will just use another slide. I will write the given now as minus 2. So we know that our numerator is u and our denominator is v. Therefore, using the formula, f prime of x is equal to the denominator. We have x squared minus 2 times the derivative of the numerator. So I will just write first d over dx of 4 square root of x minus the numerator, we have 4 square root of x times the derivative of the denominator, which is now x squared minus 2 all over the square of the denominator. That is just the same as, so if this is our u and the denominator is our v, so this is just the same as x squared minus 2 is v, so therefore v, then the derivative of the numerator du minus the numerator is u minus u times derivative of the denominator, which is now dv all over the square of v. So taking the derivative yet on this part, so we can write now as we have x squared minus 2 times the derivative of 4 square root of x. So we can rewrite first the square root of x as x raised to 1 half. Since we have the coefficient of 4, so 4 square root of x can be written as 4 times x raised to 1 half. So taking the derivative of that, so 1 half times 4 is equal to 2. So we have 2x raised to 1 half minus 1 is equal to negative 1 half minus, I can write now as 4x raised to 1 half instead of 4 square root of x times the derivative of x squared minus 2 is equal to 2x all over. We just copy the denominator. Do not expand that one yet. So we can just write here x squared minus 2. The quantity of this will be raised to the power of 2. Now, using distributive property, we have x squared minus 2 times 2x raised to the power of negative 1 half. So let's multiply the first term. So x squared times 2x to the power of negative 1 half. We have now 2x to the power of 2 minus 1 half is to the power of 3 halves. Then negative 2 times 2, we have negative 4 and copy the variable x raised to negative 1 half. And on this term, on the next term, we have 4x raised to 1 half times 2x. So numerical coefficient, we have 4 times 2 is negative 8, and multiply x raised to 1 half times x. So add the exponents. So 1 half plus 1, it gives now 3 halves all over. So copy the denominator, which is the square of x squared minus 2. So we can see that there is like terms. We have the 2x to the power of 3 halves and 8x to the power of 3 halves. So therefore, we can combine that one. So we have 2 minus 8 is negative 6. So negative 6 of x to the power of 3 halves minus 4x to the power of negative 1 half all over the square of x squared minus 2. Or you can stop your answer here even without writing into positive exponents. But if you want, you can write in this form. We have negative 6x to the power of 3 halves minus 4 over x raised to 1 half all over x squared minus 2 to the power of 2. So it's either of the two answers are accepted. Okay, so if I were you, you will just stop your answer up to this point. Okay, so next we have y is equal to 1 plus the square root of x cubed times x to the power of negative 3 minus 2 times the cube root of x. So using the product rule, I let this one as my u, and this one is our v. So therefore, so we are going to rewrite first the given in terms of fractional exponent. So we can write now y is equal to 1 plus x to the power of 3 halves times x to the power of negative 3 minus 2x raised to 1/3. So after that, so our u is the first term and the first factor, and v now is our second factor. So using the formula that I have shown a while ago, so therefore y prime is equal to u dv. So we have now 1 plus x raised to 3 halves times our derivative of the second term. We have the derivative of x to the power of negative 3 is negative 3 x to the power of negative 4 minus 2 times 1/3 is my negative 2/3 of x raised to negative 2/3, because 1/3 minus 1. So 1 minus 3 is negative 2. So I change that one into fractional exponent. That's why it becomes negative 2/3. Plus the second term, we have x to the power of negative 3 minus 2x to the power of 1/3 times the derivative of the first term. So it's now du, because u is our first term. So we have derivative of 1 is 0. Then derivative of x raised to 3 halves, which is now equal to 3 halves of x to the power of 3 halves minus 1. That's now 1 half. Then simplifying this one by using distributive property. So we have, let us start first with the first terms. So 1 times negative 3x to the power of negative 4 is equal to negative 3x to the power of negative 4. And then we have last outer terms. So I'm using the FOIL method. So the first terms are 1 times negative 3x to the power of negative 4. Then outer terms, we have 1 times negative 2/3 of x to the power of negative 2/3. So we can just write here negative 2/3 of x to the power of negative 2/3. And then we have inner terms, which is now this one. So x to the power of 3 halves times negative 3x to the power of negative 4. So the product now will be negative negative 3x to the power of 3 over 2 minus 4 is equal to negative 5 over 2. We have negative 5 over 2. And the last terms, which are x to the power of 3 halves, as well as this. So negative 2/3 of x to the power negative 2/3. So the numerical coefficient is 1 and negative 2/3. So I can just write here negative 2/3 of x to the power of. So add the exponents because we are multiplying with the same base. So we have to add the exponents. So we have 3 over 2, but the sign is negative. So I can write there so plus negative 2/3. So the answer now is 5 over 6. So that's the product of the UDV plus the product now of VDU. So multiply 3 halves of x raised to 1 half times x to the power of negative 3. So we have now 3 halves of x to the power of negative 3 plus 1 half. So negative 5 over 2 is our exponent. And the next term, we have negative 2 times 3 halves. So 2 is cancelled. So we have now negative 3. So negative 3x to the power of 1/3 plus 1 half is equal to 5 over 6. So we have x raised to 5 over 6. So next is to simplify by combining like terms. So what are the like terms there? So let's start now with negative 3x to the power of negative 4 because there's no like terms. Next, we have to write negative 2/3. So I will write here negative 2/3 of x to the power of negative 2/3 because there is no like terms. Next, we have in terms of x to the power of negative 5 over 2. So they are the same. So we can combine. So we have negative 3 plus 3 over 2. So the sum now is negative 3 halves. So we have negative 3 halves of x to the power of negative 5 over 2. Then in terms of 5 over 6, this one, and this one, so we have negative 2/3 and negative 3. So let us find the sum of that. Negative 2 over 3 minus 3 is equal to negative 11 over 3. So we have negative 11 over 3 of x to the power of 5 over 6. Now, if you want to express your answer in terms of positive exponent, so just bring down the variables and change the exponents in terms of positive. But actually, I will accept your answer up to this point. So for the last number, we have f of x. So I will just copy this one on the next slide. So for the last number of my example, so we have f of x equals the square root of x plus 2x all over 7x minus 4x squared. So using the quotient rule, so we have now f prime of x is equal to, so the denominator we have 7x minus 4x squared times the derivative of the numerator d over dx of the square root of x plus 2x minus the numerator with square root of x plus 2x times the derivative of the denominator. We have to take the derivative of the denominator of 7x minus 4x squared all over the square of the denominator. We have 7x minus 4x squared and then the square of that. Now let's take the derivative of this. This is our this is now u dv, so dv, and this is our v du, this is our du. So taking the derivative of that, so I will write first the other given. We have 7x minus 4x squared times the derivative of square root of x is 1 half of x to the power of negative 1 half plus the derivative of 2x is 2 minus, we have the square root of x plus 2x. Then derivative of this, we have derivative of 7x is 7 minus derivative of 4x squared is 8x. So all over, copy the denominator, 7x minus 4x squared, then quantity to the power of 2. So if you are going to simplify this one, this will take a very long solution. So in that case, you just stop up to this point, so that we will not have a very complicated solution. What matters most is that we applied the quotient rule. So you just stop your answer up to that point.